In this video, I'm going to talk about how to understand the parts of a graph. There are some common words that need to be considered before we get into some examples. So I'd like to go over those first. First of all, the most common words that are associated at the algebra level with graphs are the following. They are y-intercepts, x-intercepts, absolute maximum minimum, and relative maximum minimum, which altogether are called extrema. And the last is slope. And I actually want to begin with the last one, which is the slope. So let's look at that with this graph here. So we have the idea of slope is that slope can have several different definitions, but we're going to focus primarily on increasing versus decreasing. And you can see in this example over here of this graph that this part over here is increasing, whereas this part over here is obviously decreasing. And so the point at which this switch in direction of the graph happens, this right here is called the local maximum. Now, there's another way of saying local maximum, and it's sometimes known as your relative maximum. In this case, the relative maximum also happens to be the absolute maximum for this graph, but we'll look at those a little bit later. For now, just understand that when a graph is going up, it's increasing, and then there's a moment where that graph may switch. It'll level out for just a moment, and then it'll change directions and begin to decrease after that point of switch. And so that would be the part where it decreases. The slope changes from increasing to decreasing. Okay, so looking at this other example over here, we can see that we have multiple points where the graph changes from decreasing to increasing. So here it's decreasing, 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 and then all of a sudden at this point right over there, that's the turning point, as you can see over here, turning points, and it turns, and then it changes to increasing, increasing, it's still increasing, and then at this point, this is the turning point again, and then it switches to decreasing, so it's decreasing again, and we hit yet another turning point, which is there, and then it increases, increases, increases. And then one thing to note is you have arrows on these two parts of the graph, indicating that the graph just continues upward to infinity. And as far as we know, it no longer has any more turning points after what we see here. So after about that level, no more turning points, and it just keeps going up forever. Okay, so with all these things in mind, the idea of decreasing and increasing and the turning points, we can now finally look at the first example here. So in this example, the first thing that I want to note are where my turning points are. So I'm going to go ahead and mark those. I see my first turning point is there. I have another turning point, tracing it up about right there. Another turning point right here. And everything that happens from the beginning to the end, this whole graph takes shape because of these turning points. And so what I also want to note is where I begin. So if you notice over here, we have a closed point, and this is the beginning of the graph. So unlike the other one here, where we have our arrows that indicate going up forever, here we don't have that situation. Here we have a graph where we have a clear starting point, and then we have a clear ending point right there. So there is no foreverness, infinity to this graph. The place where the graph is at its lowest point would be this part right here. And the place where it's at its lowest is called the absolute maximum. So this right here is the absolute maximum. Okay, absolute obviously meaning the most, right? I'm sorry, this is incorrect. This is the absolute minimum. Sorry about that. Absolute minimum not maximum. So minimum meaning the lowest, absolute meaning the most, so it's the most lowest point. The absolute maximum, which is the exact opposite of that, would be the highest point of the graph, which would be this one over here. So this would be the absolute maximum, and it simply means the highest. Okay, so it's the highest place on this graph, whereas this one is the lowest place on the graph. And I like to indicate where these are. So the absolute maximum, the highest place on this graph, happens if I were to trace this all the way over. This is roughly about 65. So this would be, if I were to go straight down, something like 7, 65. Okay, so the absolute maximum is really given by this output value here, which is 65. That's the highest, because output does have to do with the range or the height of a graph. Whereas by contrast, the absolute lowest point, which is over here, this would be at about, and I'm approximating here, okay? So this is about 1, and if I go over, this is about negative, maybe negative 15. So again, the y value, the output, negative 15, shows us the lowest that this graph actually dips down. So negative 15, absolute minimum, 65, absolute maximum. Now, the relative max and the relative min. The relative max and min are the points in between your very beginning, which is the green highlight, and the very end, which is your other green highlight. And it's the points in between those, not including those, that are also high or low, but they don't include the very beginning or the very end. So this is why we have to look at the turning points on this graph, because we need to identify the relative maximum, which happens at the place where we have a slope change. In other words, a change from increasing to decreasing, or usually it's increasing to decreasing. So if I look, I can see that right over here, I'm going to switch my color here. So right over here, I have a point that is not the absolute maximum, but it is still a high point on this graph, and it lies in between my two endpoints on the graph, the two highlighted green endpoints. This is between those, and though it's not the maximum, it is still a high point. So this would be considered a relative maximum, and it's the turning point of this graph at that place. So this is a relative maximum. And similarly, the other point that is also between the beginning and the very end, but it's not the lowest, yet it's still low, would be that point right there. And this would be called the relative minimum. So relative minimum. And again, notice that this is also a switch point or a turning point at this portion of the graph. Okay, so we have relative max, relative min. Now the relative maximum, this location is at the following place. So this would be, again, I'm approximating here. If I were to go down, this is about 4 and roughly about 40. Okay, so the relative maximum happens at this place at 40. And again, the focus is really the output here, which is 40. I'm going to use this color here. So it's 40. The relative minimum would be down there, and this would be at roughly 6 and roughly 10. Okay, so the relative minimum here would be at about 10. Okay, you can see the difference. Our absolute minimum was at negative 15. Our relative minimum is at 10. Our absolute maximum was at 65. but our relative minimum was at 40. So I hope this example helped you understand absolute max, absolute min, relative max, relative min. There is two other things that I do want to point out, which I said I would. One is the y-intercept. The y-intercept is simply the place where the graph touches the y-axis, which is this one over here, where it runs up and down. All right, this is your y-axis, y's. And the place where that happens is in that red circle. So this would be at 0, as you can see. So my y-intercept is at 0, okay? The x-intercept is a place where the graph touches the x-axis, which would be this over here running this way, okay? This is our x-axis. So you can see that the place where the graph touches the x-axis is at the same place where it also happens to touch the y-axis, which is also at 0, okay? Now this 0 over here corresponds to your y, and this 0 over here corresponds to the x value, okay? Which is actually, in combination, our origin of this coordinate plane, 0, 0. Okay, so I hope this helped, and stop by, leave a comment, and as always, thanks for watching. Bye-bye.